Experiment 6, Chemical Equilibrium. The first experiment that took place was Part D, cobalt chloride equilibrium. Now, in this reaction, the cobalt as seen here is initially pink and the cobalt chloride is blue, which is very important to note. Now, this reaction as a whole is an endothermic reaction. The first scenario that was put in was the addition of hydrochloric acid. The stress on this was increased Cl-. Now, according to Le Chatelier, this is going to cause a shift right to consume the extra chloride ions. Now, this causes a color shift from pink to purple due to the increase in chloride ions, which increases the cobalt chloride, which was noted earlier as to be blue. Next, this was placed in boiling water along with the hydrochloric acid. Now, the stress in this scenario was added from the heat from the boiling water. According to Le Chatelier, this is going to cause a shift right because the reaction is endothermic. Now, the color shift is going to go from purple to a very deep blue due to the increase in the cobalt chloride. Next, the reaction is placed in an ice bath, again with the addition of hydrochloric acid. The stress is the removal of heat from the ice bath. Now, in this case, according to Le Chatelier, the reaction is going to shift left because the reaction is now exothermic, meaning it is the inverse of the previous reaction with the addition of heat. Now, the color change in this case is going to be from purple to pink due to the increase in cobalt. As mentioned earlier, cobalt is initially this very pink color, whereas cobalt chloride is a deep blue color. Now, the next reaction is Part F, bicarbonate carbon dioxide equilibrium. Now, the first scenario is the addition of 6 molar hydrochloric acid. The stress is the increase of H+ consuming the hydroxide. Now, according to Le Chatelier, this shifts right to produce more hydroxide. Now, in this case, the color change goes from this green color to a more yellow color due to the increased acidity caused by the production of the hydroxide. Next, the next scenario, it was connected to a vacuum aspirator. The stress is the removal of CO2 gas as it was formed. Now, according to Le Chatelier, this will cause an increase or cause a shift right to replace the lost CO2 gas. Now, the color changed from a yellowish color, very yellowish acidic color, to more of a faint blue color, meaning it became more basic. Now, there was bubbling occurred, and that was from the CO2 gas escaping. The final experiment that took place was Part C, the Farrowen equilibrium. Now, it is very important to note in this reaction that the original iron and phenterphthalein was a very clear color, whereas the Farrowen was an orange, deep red color. Another important thing to note was this was an exothermic reaction because the iron bonds released lots of energy. Now, the scenario this reaction took place under was hot water. The stress was the addition of heat from the hot water. Now, according to Le Chatelier, the equilibrium shifts left due to the decreasing Farrowen. Now, this can be seen in the color change from that deep orange color created by the Farrowen back to a clear color because the Farrowen is released, and it is now a clear color because it is just the raw iron and phenterphthalein, whereas previously it was the Farrowen deep orange color. The Honors 160 laboratory manual was used to gain the format of all the chemical equilibrium reactions demonstrated in this presentation. Thank you.